Well, you ask the universe for something, you go out into the universe, and the universe provides. There's no council cleanup days at the moment around us, and I went for a walk and I found this microwave. I had a screwdriver in my pocket and a pair of wire cutters. Alas, the screws on it are frozen. I'm going to have to get it home. So the universe has provided this trolley too. And we are presently on our way home to uncrack this thing and get the transformer out of it. And we're on our way to building ourselves, once we rewind the secondary, a linear supply for the shack. We've made it home. Well, we have managed to crack the screws on this.
Please like and subscribe.
Okay folks, the mandatory notification that playing around inside any high voltage equipment can be very, very dangerous. So only attempt this if you're 100% confident and you know what you're doing. You may see things I'm doing you disagree with. That's fine. Comment below. But I'm an adult and I can take the risk, and it's a risk that I'm prepared to take. I'm by no means advocating that you do the same. So this is the haul from the insides of the microwave, the guts of it. I haven't really gotten everything out of it. I've gotten stuff that I think is going to come in handy. And the main thing that I needed to get from this microwave was this transformer, so that I can rewind the secondary winding and get it to the appropriate voltage for a 20 amp 13.8 volt DC supply that's going to be linear and quiet. And the primary on this is a 240 volt, because it's a 240 volt microwave, or 230 volts, we're in Australia. This, believe it or not, is a 5 kilovolt, and I'm struggling to hold this thing up. 5 kilovolt, 0.6 amp, and kilovolts, because it will kill you. 240 will kill you. So you've got to be really careful with this stuff. Capacitors. This thing, I think it says, let's have a look. It's 1.1 microfarads, and it's rated at 2100 volts. That's our capacitor. I don't know what I could use that for. I don't know if it's good for RF. We have feet. Now these things come out of the microwave, they're limit switches. And I was thinking these might be fun to make a keyer out of, or something like that. I'm sure I can find uses for those at some point in time. And there was 3 of those in there. And we had our little motor that drove the food around when it's inside the microwave. And a nice little fan here. I think that's a 240 volt fan, so that's a mains powered fan. That could be used in a project at some point in time.
Cooking up a storm. Yes, what are these little greeblies? What else would someone that's half Greek eat? Some octopus. Let me know in the comment section below what you think of octopus.
What do you want to do this? This isn't just below the knuckle.
Be careful what you ask the universe for, because sometimes the universe, in fact, the universe always provides in abundance. So do you think I've got enough microwave ovens? I think I'm in a position now where I can stop collecting them, but these will come in handy if I decide to take some forays into some valve technology. And this is the case that I'm going to use to house the power supply. Look, it's not totally metal, but it's got some metal in it, top and bottom. And so this is what I'm going to chuck my power supply inside, if it fits. Now, we started this whole journey on the premise that we'd be able to use a microwave transformer for this power supply. And as you saw, we have a mountain of microwaves, which I can also use for high voltage transformers if I decide I want to play with valves. And at some point in time, that's most likely going to happen. On reading the very, very learned Drew Diamond and his discourse on these transformers, he has stated that the primary for most microwave transformers is best suited to really 120 volts, and at 240 it's running at saturation. It's very inefficient and it gets hot. Not a problem for a microwave which is run for minutes and has a fan running and then has adequate time to cool down. But for a power supply, it's going to be a problem. What I have decided I'm going to do is, first of all, I'll read you a little bit of stuff in this book. Now, what I am doing here is not something that Drew Diamond has recommended. You copy me at your own risk. I am going to take things very, very slowly, and I'm going to make sure that if I do build this power supply, that I run it under supervised conditions, monitoring how much heat it's generating and how it's performing under various loads to make sure that I'm happy with its performance before I put it into full service. Now, I managed to find videos on how to make a high amp DC supply from a microwave transformer, so I just assumed that I could apply those videos to a supply that I'd be using for an amateur transceiver. Well, the problem, of course, is that the type of transformer and the way it's wound for a microwave means they run very, very hot. And the gentleman who's built this supply, which is called the SSB 20, and I'll just scroll it. You can have a look at how he's built it. He's actually built it in a wooden box, and it says here the SSB 20 power supply, 20 amps peak of recycled grunt for SSB transceivers, but he does admit that it runs very, very hot. Now, there's heaps of videos online on how to do this, so this is by no means the definitive way to do it. You might learn a lot more by going online and having a look, but you can watch my efforts at it to see how easy or difficult it is. The main thing you got to remember is that your primary winding is enameled, and you don't want to damage that winding. So if you hit it with the chisel, when you're trying to remove this secondary winding, you can do what you like to the secondary winding. You can mangle that as much as you want, but you can't hit this primary. So I've seen a lot of videos where they put something between the primary and the secondary and they cut down. I'm going to turn this thing on its side and try working on it from the side so that if I slip, I'm not likely to go into, or less likely to go into my primary. See what we're dealing with. Clean as you go. I probably should have done this outside, but weather's not very nice at the moment, so I thought I'd stay inside. So that's where we're at the moment. I'm just going to clean up all those loose ends here and whatnot. Now we need to hammer out. So it'd be nice if I had a square bolt, but I'm going to try and use the end of this and just hammer from this side and see if I can get it moving. We'll see what happens.
See it coming out ever so slowly. But it's a little bit complicated.
As you can see, that's one side done of the secondary. I'll do the same on the other side, and we're ready to wind our secondary.
Hey, lazy boy.
Now, Drew Diamond's iconic series of books, Radio Projects for the Amateur, volumes 1 to 4. I've done a review on the channel. So jump in the playlist below if you want to have a look at that review. A great set of books. I didn't read this book well enough when I started this whole journey on creating a power supply. And so when I went to have a look at rewinding transformers, I was a little bit aghast to find out that I'd need to find an old TV transformer. And those TV transformers are very, very difficult to find now, having sets that now use switch mode supply. So I was thinking, oh no, what am I going to do with that horrendous pile of microwaves? I can use it for high voltage situations. So in volume 4, this is what he has to say about microwave transformers. A few successful enthusiasts have had some success with transformers rescued from defunct microwaves. They certainly look attractive to the handy amateur. Let me list some of the features. Cheap, I got them for $0. Well made to high electrical and mechanical standards. Core primary rating of about 400 to 500 VA. Reworkable for low and high voltage PSUs. Large volts per turn. Crude voltage regulation provided by running in saturation mode. And quiet operation due to welded laminated core. Now, the disadvantages are increasingly poor efficiency when operated above about 200 volts AC primary, and therefore they run very hot if powered continuously. Secondary HV winding connected to the core, that's easily altered, and the welded core makes disassembly impossible. So, online, I'm finding videos on how to make a DC PSU, but it's for things like electrolysis or for arc welding, things like that. So it's spot welding. So it's not really the same situation. But in this book, when he starts talking about operating these with high voltages, he talks about creating less of a standby current when it's just sitting idle with no load on, by putting two in series. So we have a 1.5 amp current, which can be dropped down to about 180 milliamps or so by pairing two up and putting the primaries in series. So you then have a primary, each primary taking 120 odd volts, 115 at the moment because the AC is now 230. So you're going to have a much lower current. Keeping in mind, of course, too, that just because you've got a current there doesn't mean it's all lost power, because you're having to multiply it by the power factor because you're dealing with an inductance because it's a large coil. So there's a whole lot of very technical stuff going on. These transformers have what's known as a magnetic shunt in them, and it says here, I'll go back to the Bible. In its usual application, the transformer runs in saturation mode where the primary magnetizing current is quite large, typically 1.5 amps. This, together with the magnetic shunts fitted to the core, provides a degree of output DC voltage regulation, and so allows, pardon the helicopter in the background, so allows for a wide range of loads upon the 2 kilovolt secondary. So we are going to remove those shunts because it's certainly not helping efficiency. We'll knock them out, and I'll show you the jig that I built to get that done without damaging the primary, where they're going to have to strip out another transformer of about the same size, and we're going to run them in series for the primary and in parallel for the secondaries, and that way we've got plenty of dissipation for any inefficiencies that are occurring, and we're operating the primary at a voltage that it prefers. So hopefully our idle current will be a lot lower, and we'll have a way of building our supply without having to shell out $100 odd for a toroidal transformer. I know you might think, gee, that's a lot of effort to go to save $100. And by the time you buy all the parts, you could probably just go and buy yourself a switch mode. Switch modes are certainly getting a lot quieter than they have been in the past. But I'm here to build, I'm here to learn, and I'm here to try and reduce the amount of RFI in the shack. So I know sometimes I've got my LED lights flashing away in the background in these videos, and you're probably going, well, they're pretty noisy. I do usually unplug all that stuff when it's not in use. Anyway, enough of me babbling on. Let's get this first transformer wired up, and we'll just have a look at what current it's drawing in idle and how hot it gets and all that sort of stuff. And we might get an idea of, how it performs on its own, and then we'll be able to compare it with a situation where I put two of them in series. And down here, we have the jig that I've built. It's rough and ready. I can probably chop these off, and at some point in time I will. No, that's not going to happen. But the reason why I built this this jig is because when we put this down and we knock the shunts, and the shunts are in there, and we want to knock those shunts out, we have to be very, very careful when we sit this on the ground because we're going to damage our primary enamel. So by putting it up on this jig that I've built, we're able to knock those shunts out without damaging the primary. And I can probably even get a clamp on either end of this and clamp it down so that it won't bounce off and move around. So this should work quite well. We are clamped and ready to go. Well, way to go. We thought we were filming, but this is what the cores look like. And to knock them out, all I had to do was get this screwdriver, make sure that I leave a bit of distance between the primary, and then just go tap, 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 and they just popped right out. Now I'm going to keep those too because I can use those to create an insulator. I'll probably cut a little bit of Perspex or something that's a good insulating material, just so that we keep a little bit of separation between our primary and our secondary windings. Admittedly, the wiring I'm going to use for the secondary is going to be well insulated and of a good gauge for the current that's concerned. But we just want to make sure that we have a bit of separation. Now, for a high voltage situation, this would be imperative. For this situation, it's probably less of an imperative, but we'll put it in there nonetheless. Now, I ended up using mains cabling wire that's rated at 20 amps. Ideally, you'd be using cable that's rated at above 20 amps, but there is a reasonable factor of safety, I imagine, on those cables. And that's what I had to do to get the necessary amount of windings in to get the secondary to the voltage that I needed, which is around 20 volts. So we ended up getting close enough, I think, to actually build the supply. Keeping in mind that I'm operating QRP, so I'm very, very unlikely to need to be up around that. So I think the power supply build will run a 100 watt rig for SSB, and you'll probably need to run it on things with a higher duty cycle at a lower power. But look, it's certainly going to be less noisy and less of a problem than the present switch mode I have. I ended up putting about 18 turns on the secondary. We'll watch the video and you'll see. I got a bit of a surprise. I think this transformer is going to be okay. And then you have the resting current, 101.7 milliamps. So I don't know whether this is a weird transformer or what's going on, because we're expecting a lot higher than that. But we'll pop over and we'll have a look at the output AC voltage as well. So we'll just swap this to this to volts, and we'll have a look at what's coming out in the secondary, which is the thicker wiring.
And as you can see here, we've got about 18 volts. I would have preferred a little bit higher than that, but I can't squeeze any more cable through this thing on the secondary, so that is going to have to be enough. So hopefully we can get this supply to work. This transformer is a work in progress. May or may not suit my needs. I'm going to be very, very careful about how I implement it in the power supply that I intend to build with it.
And now that we've got a transformer that appears to be working, we are going to go shopping. And here we have the capacitor, electrolytic, screw down capacitors. You can screw the connectors onto it, and 63 volts at 47,000 microfarads. So that is what I'm going to be using to filter my supply. Now, Drew Diamond offers in his book, if you can't find the manganese wire that you need to actually make a shunt, he'll send some to you if you send out a stamped self-addressed envelope. So ever the gentleman, but I'm not going to bother Mr. Diamond. What I've done is I've gone online, and as you can see here, this thing will read voltages from 0 to 100 volts and amps up to 50 amps, and it comes with a shunt. So this is what I'm going to be using on my power supply, digital display, bringing it up into the 2000s. I would really love to put a panel meter on it, don't get me wrong, but they're very expensive and I don't have any in the junk box.
So we have our transformer ready to go. I've ordered parts for the power supply. I'm very, very excited about that. I'm going to be waiting for some of those parts, slow boat from China. When they all arrive, we'll start construction of the power supply. I can probably start buying other parts I need and doing other sub-assemblies and whatnot before the arrival of some of the parts. In the next few videos, hopefully, or in videos to come, you'll see that power supply in action. Hope you've enjoyed the video. Thank you for sticking around right to the end, and I shall see you in the next episode of The Art of Engineering 7.3.